And welcome to A3 Cross-Site Scripting Mitigation Countermeasures and Defenses. Now for our defenses overview, we are going to look at the twofold mitigation strategies. And those two components include input validation and output encoding. Now the reason I am putting them together is because in addressing any cross-site scripting attacks that we looked at, you need to incorporate both of these in order to properly mitigate the problem. Now for input validation, we are speaking only in terms of server-side input validation. Never do we want to have any validation on our client side. It is very for the attacker to manipulate any kind of validation checks that are done within the browser. We are going to look whitelisting, blacklisting, and regular expression, which are common with input validation. It is done if you don't have a built-in framework, method, or a function available. And then we will take a look at a sample code showing some input validation. The other main area is output encoding. Now output encoding is going to neutralize any kind of special character that might be misinterpreted by either web server or web browser that might be contained in it. HTTP response. So what output encoding essentially does is it forces a conversion of all characters to some sort of character scheme or a character set. Now, why this is set advantages? Because that forces the character to be triggered as data instead of the web server or the web browser actually executing malicious scripts unintentionally. Generally speaking, URL encoding is used for output encoding and it usually confirms UTF-8, and I will explain why in just a moment. We will also look at the code sample of that, and also I am gonna go through output encoding web page context that you need to make sure that you include when you are going your defensive coding. Now input validation. As I mentioned, if you do not have something built in your framework already, these are some alternatives: whitelists, backlists, blacklist, and regular expression. Now whitelist we spoke about in A1 injection as another difference there. These are the same ones. Basically, you are going to define your whitelist to be as specific in the type as possibly can, yet wide enough to still allow for the business functionality to still maintain in the page. Now what I mean is, if you have a text box that only receives a name, then you should only receive alphabetic characters. You should not receive any numbers. That's just one example. So obviously we have gone through whitelist, and what they do is they only allow acceptable values to pass through. And this acceptable value can actually be defined in an array enumerations. Possible constants can be defined in the header or common area, and also regular expression pattern matching. Now block lists are exactly the opposite. They are going to reject malicious characters that are defined in the listing. But realize that those are just malicious characters that are known at the time of writing. And so that makes a blacklist very limited in their effectiveness. And remember that every time there is a new exploit and a new way to get around the blacklist, that's going to require more manual updating of code and decompiling of the code, etc. So the preference is to always go for the whitelist instead of blacklist. And then finally you can use regular expression. Of course, regular expression could be part of your blacklist if you like. That does require learning of regex pattern building. You can consult very good books by Riley and Subject, but the good example here I have is less than sign, greater than, forward slash, exclamation dot. This actually is a regular expression, the exclamation meaning not and the other character meaning literal. And so this can be used in a blacklist to not accept any of these characters. But as we talked about before, you can use URL encoding easily to get around the blacklist of this type. The illustration is just an example to how to create and understand on how to build a regex. Please do not use one regex pattern to have all of the fields in your entire web application. That basically makes the validation completely nullified. So that's why we are saying to go back to the business purpose for a particular field. See if you can identify what would be acceptable and then create a special whitelist field for that. And you have and you have repeated fields in every application name, address, etc. And so you should probably come up with a common library that address those common types so that you can reuse the given regex patterns. Now looking at input validation code sample, as we saw before in our explanation section, we have a variable from our client side called first name, and we can get the value stored in that variable very easily from our request object. We can call getParameter method, and then we can take that value whatever might be stored in that variable and assign it to the local variable. In this, it's called first name parameter. Now, instead of immediately starting to use first name parameter, what we would do is pass that value to some sort of input validation. And in this case, whitelist is made from a regular expression. Now, in a regular expression, here I have declared as my data validation whitelist. It is set to receive only alphabetic characters, so we receive A to Z and capital A to capital Z every single letter. That means that there should be some sort of characters or number or special characters that is contained in the first name variable that is not conformed to this pattern. It would be rejected. And so if you look at the method must pass whitelist check, you can know that's how it's done. We have a pattern that matches that passes in the value that we receive and then compares it against our regex. If something does not match, then we are throwing a custom exception. So this is an example of how you can do the same in your code. Now let's talk about output encoding. So as I mentioned, output encoding helps to neutralize character, particularly in our HTTP response that we send back into the browser. And URL encoding in particular is the general standard that is used by web servers for display of characters as well as the receiving of characters, which is why you see a lot of attacks done with URL encoding for the input if you have noticed. And this is for the very same reason, just the flip side of the coin if you will. And that is to ensure that web server actually understands these special characters, and so the attacker will send that input URL code encoding. Well, it can be used in defensive way as well for the HTTP response. And so URL encoding actually replaces the character in strings with one or more character triplets. Now what I mean by triplets is basically it's going to be a dollar sign followed by two hexadecimal. For example, %2e is actually the dot notation. So the dot meaning incorrect directly. Now you should realize that UTF-8 is the most dominant character set that is generally used these days for URL encoding, and is the main reason why the first 128 values of UTF-8 actually maps directly to the United States ASCII codes. If you take a look at the example I have below, you can see the Unicode point. The the actually character which is recognized that character literal, and then you can see the UTF-8 hexadecimal number. So what we have here is a less than sign is going to be represented in UTF-8 as 3C, which means in URL encoding it's going to be %3C. If we look at the greater than sign, it's the same idea. We have the greater than sign in ASCII, but in UTF-8 it's going to be represented as 3E, and in URL meaning %3E. And so taking the sample code and continuing the output encoding, we can see how we can take the response that we are going to send back from this HTML page that's going to echo hello and someone's name, and see how we can instead send it through a regex list to sanitize it, and also on the response on the way out send it through some sort of encoder. Now the encoder that I'm showing on this slide is actually a Java encoder library that is available through OWASP. But many frameworks these days have built-in encoders that you can call, and so you would pass in your sanitized variable name into that encoding method or a function prior to send it back out to your web page. And then finally, I want to make you aware of all the mini contexts that need to be encoded. And I know that this can be a bit dizzy because you don't realize just how many attack factors are available on the website until you start watching a lot of demos or see a lot of exploits done. But this is to make you aware that it's very important that you provide encoding for all of the different contexts that might be available on your web page. So at a minimum, you should look at these contexts: HTML body, HTML attributes, your URL, and any JavaScripts that's in there, including JSON, jQuery types, cascading style sheets, etc. Now, generally, you would have some sort of library that would be able to encode for all of these different contexts for you. What I'm showing is the drop-down list for the encoder that I had just mentioned on the previous slide. But look inside the encoder of your framework and make sure that different contexts can be encoded. Thank you.